So hello and welcome to this channel. And today in this video we are going to learn about how to find electric field due to an arc. Arc means suppose one wire which is part of a circle and it subtends at angle alpha at the center, and we want to find electric field due to this arc. So here we consider a circular arc of radius r and uniform charge density, that is lambda, and we have to find electric field at the center of the circular arc. So at this center we want to find electric field, or sometimes instead of lambda they will be given q, so we can write lambda, that will be equals to what, q upon r alpha, or in terms of lambda we can write, right? So let us see how to find. So here we consider a circular arc of radius r and uniform charge density lambda. So now we consider again, since we have a continuous charge body, so we have to take one small element, and due to that element we have to find electric field. So here again angle is changing, so we consider one element at the angle theta from the angle bisector, and the element subtends angle d theta at the center. So for this small element, so we can write, for a small element, for this small element we can write dq, that will be how much, dq will be equals to again lambda into length is how much, r d theta, r is radius and angle subtended by this element is d theta, right? So lambda r d theta, right? This is the angle subtended. So now due to this a small element dq, we can find electric field dE, that will be equals to k dq divided by r square, right? And r will be same radius r square. So here now put the value. So k dq we can write lambda r d theta divided by r square. Now one r we can cancel. So we have d, that will be equals to k lambda d theta divided by r. Now if you consider one more element at this point having same angle theta from the angle bisector at this point, so this dE will be in this direction, right? Now again we can break in two parts. This will become how much, dE sine theta, and in vertical direction we have dE cos theta, right? So d sine theta we can cancel out. So we can say that if we consider, so consider other small element at symmetry, of course. So in that case dE sine theta cancels out. So dE sine theta cancels out. So now in this case we can write E net at the center, that will be E net, E net, that will be equals to integration of dE cos theta only, right? And from where to where? See, again now limit is very important. Here we are taking from angle bisector, from midpoint. So if you consider this is the arc and we are taking from the angle bisector from here. So when we are at this point, so angle was how much? 0. So if we consider from this point, angle is how much? Minus alpha by 2. And when we are at this point, last end of the arc, it will be how much? Alpha by 2, right? So limit should be from minus alpha by 2 to alpha by 2 or theta, whatever angle they give. So here now we can put the value. So we have k lambda by r, which is constant, we can take it out, and we have cos theta d theta from minus alpha by 2 to alpha by 2, right? So now do the integration. So we can write it as, we have a dE, that is equals to k lambda by r integration of cos theta d theta from minus alpha by 2 to alpha by 2. So cos theta will be how much? Sin theta. So we have k lambda by r, and now we have sin theta from where to where? From minus alpha by 2 to alpha by 2. So we can write this is total E. So E that will be equals to k lambda by r, and this will become how much? Sine alpha by 2 minus of sine minus alpha by 2. So minus of sine minus alpha by 2, and we know that sine minus theta is minus sine theta. So this will become how much? 2k lambda by r sine alpha by 2. So net electric field will be E will be equals to 2k lambda by r sine alpha by 2, right? So this is our final formula due to the arc. So now there are few special cases in this case where we have one quarter of arc. Quarter means angle is how much? Pi by 2. So we can write E due to this arc, that will be how much? We can write E that will be equals to, here now alpha is how much? Pi by 2, right? So E that is equals to k lambda by r sine alpha by 2. Alpha is already pi by 2, so it will be how much? Sine pi by 4, and sine pi by 4 is how much? Uh, sorry, 2 E was equals to 2k lambda r 2k lambda by r sine alpha by 2, right? So sine pi by 4 is how much? 1 by root 2. So this will become how much? K lambda by r and 2, and this will be 1 by root 2. So this will become equals to root 2 k lambda by r. Now in second case, theta is how much? Alpha, that is equals to pi. So now we can write E that will be equals to 2k lambda by r sine theta by 2, that is pi by 2. Pi by 2 is 1, so it will be equals to how much? 2 k lambda by r, and in this case again direction will be along the angle bisector in this direction, right? When it is complete circle, so theta or alpha will be equals to how much? We can write alpha that is equals to how much? 2 pi. So in this case now we can write E that will be equals to how much? 0. Or we can say from symmetry, from all the sides that parallel uh, along the line joining, they will get cancelled out, and net electric field will be how much? 0 at the center of a ring, right? In next part we will see the electric field due to a ring along the axis. So thank you, bye bye.